At this point in the engineering design process, it is time for us to begin prototyping our selected solution. Prototyping is the iterative process of developing a solution to our design challenge. It can take a long time to develop a prototype, yet students report that this is the step they most look forward to. It is true that this is the most tactile and hands-on of all of the steps in the engineering design process, and so it's important for you to educate yourself on as many aspects of prototyping as you can. There are many purposes of prototypes. The first is to communicate a design idea. The next may be to test a feature, an idea, or a concept. Maybe your team wants to explore some brainstormed ideas or compare some potential design solutions. The most important purpose of a prototype is to build a representation of the solution for your design challenge. Prototyping is not limited to physical objects or solutions, and it can be completed for computational projects. And that's because the process of prototyping is methodical and iterative. Prototyping is an iterative process. This is a central feature to the prototyping process. And another way to state this is that prototypes evolve over time. Evolution of the prototype is the process the prototype or component moves through as they change one or more of the following: complexity, fidelity of materials, functionality, or features. This requires iteration in order to be made. This means that prototype 1 should be different from prototype 2 and different from prototype 3. There are a number of big questions that relate to prototyping, and the first one that teams usually come up with is, what type of prototype should we build? So over the next several slides, we're going to cover different types of prototypes. One of the first types of prototypes that your team is going to build is either a representational prototype or a functional prototype. A representational prototype is a non-working model of your intended solution, and the goal of this prototype is to communicate the idea of the project to stakeholders, clients, or your team. Aspects of a representational prototype symbolize other design blocks or features. It's useful to use a representational prototype when it is impractical to make a functional prototype. It's also useful when technology already exists and is well understood. An example of this is that a hinge can be represented by a piece of tape in your prototype. A proof of concept prototype focuses on exploring or testing a specific design block. The goal of this prototype is to demonstrate a basic idea and answer the question, does it work? All throughout the engineering design process, you may create proof of concept prototypes to explore uncertain ideas that you have. These proof of concept prototypes are often low fidelity and created quickly to answer this question. A functional prototype is a working version of your intended solution. The goal of the functional prototype is to exhibit the intended functions. Aspects of a functional prototype match the intended utility of the solution. Functional prototypes are the most common type of prototype, and they should be used whenever possible. An ergonomic model deals with how people interact with the device. It could relate to the shape or the shell of the device, and it is most often a representation of the device or object that is to scale. Another decision your design team will need to make is whether to build a component-based or integrated prototype. A component prototype has one design block or discrete part of your solution in it. And the goal of this prototype is to isolate this individual aspect to focus on its evolution. A team can iterate on one component in their design. An integrated prototype is one which contains the combination of many ideas and individual components. And the goal of this prototype is to test the combination of multiple functional components. Another big question is, how do I start prototyping? A good first step would be to determine the goal of the prototype. For example, the goal of your prototype may be to test functions or individual design blocks. A logical second step is to select the materials and tools that you will use to build this prototype. A general rule of thumb is to construct these initial prototypes in less than 30 minutes. So if your prototype is going to be physical, a good place to start would be to use paper or cardboard. But if your project is electrical or computer science related, another good place to start might be to write out a block diagram or a flow chart for these electronics and computer parts. Here's a key tip. Quickly move through your first few prototypes. This will help gain consensus within your team on design ideas, features, and to check the functional parts of your project. It's a good idea to start the prototyping process fast and then slow down as you refine your prototypes. Here's an example of some low-fidelity prototypes created quickly. On the left is an iPad holder built from construction paper. In the middle is a novel elbow mannequin made from balsa wood and rubber bands. At the right is a model of a water feature for foot washing. The paper strips represent the water, and the cardboard the structure. With every stage of prototyping, you should evaluate your prototype to determine what works and what doesn't work. Evaluating will help guide your thinking and help shape what the next prototype will look like. In the middle of the prototyping process, you should focus on using more advanced materials. This could include materials that hold their shape, are more difficult to work with, or that look more like the final product. Prototyping is an iterative and evolutionary process, which brings up another big question. Where do you end with your prototype? Ending the prototyping process, or moving on to a higher level of fidelity with your prototyping, is a good idea when the following is true. First, your current prototype meets the desired functions. Second, it meets the design criteria. Or third, when it looks like the final product. With this in mind, it is still okay to have artisanal defects present in your prototypes. The prototypes you are building are fueled by your imagination and limited by your practical expertise building things. So even if your prototype fulfills your design criteria, it might still look ugly. And I want to give you permission to be proud of your work, and I want to remind you that it is not supposed to look like a final product. It is supposed to solve your design challenge. To conclude this video, we've compiled a short list of best practice or pro tips for prototyping. First, go fast. Second, use your imagination to apply available materials. Third, build each prototype with goals in mind. Fourth, always stay safe. Fifth, order materials early so you don't fall behind. And finally, build without fear.